So example 3, a fire truck has an 84-foot ladder extended against a building forming a 55-degree angle with the top of the truck. All right, so we have a fire truck here. It's a hover truck, it has no wheels. And we have a building here. Here's our building. And the building is, the window's 75 feet above the ground. So there's a window in the building. Let's just say the window's right here. And the distance from the ground to the window is 75 feet. The ladder is being extended from the truck. Let's just say the ladder is extended from here. And they're going towards this window over here. And it says the ladder makes a 55-degree angle with the truck. So there's my 55-degree angle. All right. Figure's not drawn to scale, by the way. The ladder is 84 feet long. The truck is 8 feet tall. So this is 8 feet here. So what you need to do in this chapter when you're drawing these pictures is you need to be able to see right triangles in the pictures and use the right triangles to do the SOHCAHTOA stuff. So if I'm looking at this picture here, that's what they described to me. We've got an 8-foot tall fire truck. The ladder's on the top of the truck, forming a 55-degree angle with the top of the truck. It's extending up to this window, maybe, because they're asking if we can actually reach this window or not. That's 75 feet above the ground. That's what's going on in this problem, based on what we see. Now, one thing I can make an assumption for is that 55 degrees is probably the maximum they can go up. They can go shorter, right? Probably. So if I can get 75 feet or more, I'd be able to drop the ladder down lower to get that 75 foot high. So that's kind of what I'm looking for, is can we reach that high on this truck or not? So that's what's going on. And if I'm trying to find a right triangle in this picture, I'm going to do it like this. Here's my window. I'm going to draw it down to the top of the truck, and then I'm going to go across here and there. So again, I want to see right triangles in the pictures. Now if you take a look at the right triangle that I see, here's my right angle here obviously. This is my acute angle that we're going to probably work with, the 55-degree angle. I'm able to find this measure over here, x. X is the distance from the window to right here, which is level with the top of the truck. This little piece here is 8 feet. So, looking at the picture, I need to make sure x here has to be at least 67 feet to add to the 8 feet to get up to the 75-foot window. Right? So, the truck's 8 feet off the ground, or the ladder's 8 feet off the ground. So, it's level with the spot 8 feet off the ground here. As long as this x value is at least 67 feet, we should be able to reach the people in the window and save the day. Right? Looking at the picture that I've got going on here, once I establish the right triangle I'm going to work with. So for me personally, maybe I draw this picture, but the thing that's really key to me is this right triangle. So if I extract the right triangle from the picture, so I can just look at what I'm looking at, again, not drawn to scale. We have a 55-degree angle down to the bottom right-hand corner with a right angle in the bottom left. We are trying to find the height of the building, and we know the length of the ladder. Okay. If we happen to know the horizontal distance, we could use the Pythagorean theorem. We'd have two sides, right? But we don't have two sides. We only have one side and one angle. So if I look at this using the idea of trigonometry, I'm using this angle. For that angle, the opposite side is x, because I got to go across the triangle. The hypotenuse go across from the right angle is 84, and this side down here is the adjacent side. If we look at SOHCAHTOA, anytime I'm in right triangle world and I'm trying to do trigonometry, I'm going to look at SOHCAHTOA. When you're doing a right triangle problem and you're trying to find a missing piece with SOHCAHTOA, you know one side and you know one angle. Here's the question I want you to ask yourself. What do I know and what do I want to know? Because if you know one angle and one side, you're going to know a side and you're going to want to know another side. That's what's going to happen. So what do I know? What do I want to know? So for the side measures, what do I know? I know the hypotenuse. What do I want to know? I want to know the opposite. Do I care about the adjacent? No. If I don't care about the adjacent, anything involving the adjacent out of SOHCAHTOA is not going to be helpful to me. So the only trig function that's going to be helpful to me in this problem is going to be sine, because it involves the two things I care about. What I know, hypotenuse, what I want to know, opposite. So if I take this picture here and I use SO of SOHCAHTOA to create a sine equation, it's going to be sine of the angle we're working with. I put it over 1 every time. Equals, and then OH means opposite over hypotenuse. In this case, opposite is x, hypotenuse is 84. The only unknown there is x. Your calculator will know the sine of 55 degrees. So I'm going to type in sine 55. In my calculator it says 0.8192. Give me 4 decimal places in your work when you're doing trig problems. Again, it says 0.81915, so the 15, the 5 makes the 1 go up to a 2. And then it's just a proportion, numerical proportion. You're going to cross multiply. 1 times x equals 84 times 0.8192, which is 68.8128. So going back to my building picture here, x is equal to, let's go 68.8 feet. The distance up here is 8 feet, so altogether that's 76.8 feet that the ladder can extend. So that if they dip it down just a smidge, they'll get to that window and save whoever's in there, and all will be well, right? So, will they be able to reach the window using the ladder set at this angle? You can say yes. All right? Obviously, if I was a firefighter, I'd probably dip it down a couple feet, be right at the base of the window, but anyway. But again, see right triangles in the world, use SOHCAHTOA. If you have an angle and a side, what do I know, what do I want to know, creates the proportion, and the proportion the calculator knows the sine, cosine, or tangent of that angle. Cross multiply to get the answer, and you're good to go.